Hello and welcome back. I'm Astidian, happy to go over the more geometric series with you. So in this video, we're going to be talking about a sum of a finite geometric series. I am going to go through all of the examples in this video. So after the first or second example, if you feel like you have the hang of it, you're welcome to deck out. But if you want all the practice on finite, this is going to be the video for it. So let's just dive right into it. Okay, so we have the equation, first off, which is a sum of a finite geometric series. Now, I am going to change this a little bit. Now, just a reminder, okay, this A is really meaning A1. Okay, back in the vocabulary, they do imply the same thing. Now, the changes I'm going to be making to this particular equation are as follows. Okay, this set of parentheses, that's not optional. These parentheses must be here. Normally, it'll depend on the number, right? Not always will the parentheses affect it, but like 9 times out of 10, it will make a difference in your calculator. The most common mistake I see when students are using this isn't that they can't figure out it's geometric. It isn't that they can't figure out it's finite. Normally, the problem is that they cannot put it into their calculator correctly because they do not use parentheses. I'll say it again and again. Parentheses are so important. And it's always the one mistake that I keep saying. Okay, don't make that mistake. Learn from past students. Okay, the other set of parentheses that you need is I'm just going to put on the bottom here. Okay, if you don't already do this particular arithmetic and you just want to put it straight into your calculator, that other set of parentheses in red has to be there. Okay, all right. So essentially, I'll just read the equation. So it's your first term multiplied to 1 minus your common ratio raised to the nth power. Now notice this n is on the inside. It's not on the outside of the parenthesis. The n isn't over here. This n is solely over the common ratio. All right. Also notice that this negative is not included in the parenthesis. Okay, so if r is negative on its own right, it'll have to be inside the parenthesis as well. Okay. And then it's all over 1 minus the common ratio. And that is the sum of n number of terms, meaning finite. It has to end somewhere. There has to be that last term. Okay. So, example 2, evaluate each sum. Now, I wrote a kind of set of steps on your arithmetic series. I'm going to do the same thing here. So, the first thing is just identify the information you need. So identify your first term, your common ratio, and your number of terms. And then it really just boils down to plug into the formula. I know, that O was getting super sketchy. Alright. Okay. So, first thing I want to look for, I'm asking myself, is this geometric or arithmetic? And looking at it, we'll notice it goes from 2 to, 2 is between 1 and 3, 3 to 9 is 6, right? We're not adding the same thing, so it cannot be arithmetic. But, we'll notice that if we go from 1 to 3, we just multiplied by our 3. To get to 3 to 9, we multiplied by 3, 9 to 27, so we are multiplying by the same thing, and because we have that repeated multiplication, it makes it geometric. So your common ratio is what you're multiplying by, which is 3. Alright, your first term is going to be right here, your first term, so a sub 1 is 1. And then, as mentioned before, in the writing segment notation, it's just easier to fill in the dots on this one, so let's go ahead and do that. I'll do it in a different color. So 27, and then we'll just use a calculator if you don't know this. 27 times 3 is 81. 81 times 3 is 243. And then, 243 times 3 is 729. So if we count this up, 1, 2, 3, 4, 5, 6, 7, n is 7. Again, be careful not to double count terms. If you write 729 down here, make sure you don't double count it. Okay, so just be aware of that. Alright, so now you have everything you need for the formula. So we're doing the sum of n terms, where n is 7. So s sub 7 equals your first term, which is 1, multiplied to 1 minus your common ratio, which is 3, set of parentheses, raised to the n power, close parenthesis, all over, parenthesis, 1 minus 3, close parenthesis. And because you have those parentheses in there, those parentheses in red, you can plug this right into your calculator. Now, because this is just a 1 here on the outside, you don't actually need to put that in there. That can just be invisible and it'd be the exact same thing. Okay? So if you actually plug this straight into your calculator, you're going to end up getting 1,093. Okay, how you show your work on problems like these is essentially showing me what you are plugging into your calculator. If you tell me that, that is the equivalent of your work. Okay, because if I can see if you have the correct thing written down, but your number came out super weird, I will give you full points for it. Okay, but you have to have that written down for me to give you credit. Alright. So, if we wanted to do this out by hand, then it would have been 1 minus 2,187 over negative 2, which would have been negative 2,186 over negative 2, which is 1,093. So either way, you could have done it, right? If you write it out in steps like this, that is also totally acceptable. Okay? But just keep in mind that these parentheses must be there. Okay, in this particular problem, the 1 over the 3 on the top, that one actually didn't, okay? But just get in the habit of it. I promise you it will totally save your bacon on later problems. Okay? So just keep that in mind. Alright, so let's move on to the next example. So this one is already in sigma notation. So we still do the same steps. We need to get our basic information out. So our first term is what we get when we plug in the lower limit. So we start at 1, so we're going to be plugging in 1. So 1 half to the 1 minus 1, because lower limit k equals 1, so we plug in 1 to start out with. And then we just simplify it to get our first term. So 5 times 1 half, 1 minus 1 is 0. Anything to the 0th power is 1. So our first term is 5, because 1 times 5 is 5. Alright, then we move on to our common ratio. Now, this is similar to the question we kind of asked up here, is how do we write repeated multiplication? And that is your exponent. And that repeated multiplication is the pattern, right? It's what's being multiplied again and again and again. So what we're looking for here for our common ratio is the number that's being raised to the exponent. And in this case, the number being raised to the exponent is 1 half. The reason why we don't grab the 5 here is because 5, by order of operations, is outside of the parentheses for the exponent. Okay, order of operations takes care of the exponent first before it even touches the 5. So your common ratio is 1 half. So it's being brought to that repeated multiplication, brought to the exponent. Okay, and then we do our number of terms. Now, because our lower limit is 1, our upper limit is then our number of terms. It's our n, which is going to be 10 in this case. And then we do the same thing as we did before, where we plug it straight into the formula, and writing down what that formula is your work. So the sum of the first 10 terms is your first term multiplied to 1 minus parentheses, your common ratio, oops, as it turns that into a straight line, common ratio raised to the n, right, all over parentheses 1 minus 1 half. Now, if you're like, Miss Diddy, does this 1 half, because we have it in parentheses up here, do we need the 1 half in parentheses down here? I would say, go for it. Do you have to? No. But if it makes you feel better, by all means, put another set of parentheses on that sucker. Okay? So I'm going to take them off just for kicks and giggles. Right? And then I'm going to use these two little squigglies. It looks like an equal sign, but it's squiggles. That means approximately. Now, if you use the squiggles or not, I'm not going to care. Okay? It's just mathematically correct to use the squiggles. Ooh, now I'm not going to try spelling approximately today. Alright, so then we have approximately 9.990. If we were to actually plug this into our calculator, this is this number, the next digit right here, is going to be less than 5. So we don't round up, we just we'll keep the number the way it is. So that's why the 0 has to be there. It is a significant digit. Now, when in doubt, I always say round to that third decimal place, right? So 1, 2, 3, round to that third decimal place there. Okay? When in doubt, always do it. Okay? For anyone who's taking any math classes past this, most math classes like 1050, 1060, occasionally 1010, you don't see it a lot in 1010, but especially calculus and a lot of higher math classes will always go to 3 or more decimal places. Rarely will you see it to the second decimal place. Okay? Alright. So if you're kind of wondering how to put this into your calculator, it depends on the calculator you have. Some of you are actually able to put it into a fraction, but essentially what you do is you start up here and you end down here. Okay, so what this is actually going to look like in calculator form is that you write 5, and then you don't have to use multiplication sign. As soon as you put the parentheses there, it's going to be implied. So 1 minus parenthesis 1 divided by 2 parenthesis, and then generally most of you have the caret button, so caret 10 close parenthesis divided by parenthesis 1 minus 1 half close parenthesis, or 1 divided by 2. Okay, so that's how it should look like when you put it into your calculator. Is that you start at that 5 up there and then you end it with that bottom parenthesis. And if you put it in exactly like that, you will have 0 problems, 100% correct. Alright? Alright, last but not least, we have one slightly-ish scary looking example for our last finite sequence. So this one's going to be a little bit harder to see. Now, if you ever do have the question, you see something like this and you're like, Miss Diddy, I have no idea what on earth is happening. I can tell it's not arithmetic right now because we're going from positive 6 to negative 3, so that's subtracting 9. And then here, we're going to be adding something because now it turns positive. So right now, I can tell you right now, not arithmetic. But what we can do here is that we can actually take, for your common ratio, you can always find it by taking your second term and dividing it by your first term. So your second term, which is negative 3, and divide it by your first term, and then simplify that fraction. So your r is negative 1/2. So that's why it's alternating between negative and positive. It's because when you multiply by a negative, positive times a negative is negative, negative times a positive is positive, and that's where that alternating is coming from. You'll notice that the 3 is kept on the top because when you multiply fractions, you multiply straight across, so that 3 is only being multiplied by 1. But we'll notice the bottoms here are getting multiplied by 2. So now this just becomes a matter of filling in the blanks. I'm going to do that in a different color again to find our number of terms. So negative 3 halves to a positive 3 eighths. 3 stays the same, the 4 is multiplied by 2. Okay? And then a positive multiplied by a negative 1/2 is going to be a negative 3 16ths to a positive 3/32. And then when you multiply it again, we'll end up back at negative 3/64. So we'll count that and we get 1, 2, 3, 4, 5, 6, 7, 8 terms. And then we write our first term, which is 6. And now we have all the information we need. Okay, now we have all the information we need. So now we would then go from the sum of n, which is 8 in this case, and then we plug in a 1 multiplied to 1 minus parentheses r negative 1/2 raised to the 8th power parenthesis all over parenthesis 1 minus negative 1/2. And if you plug it into a calculator just like that, you are going to be getting another decimal on this one, as I recall. Let me double check it really quick. Yep, you're getting another decimal on this one. So it is approximately, you should be getting 3.984. Okay, so just another reminder, make sure you're looking at this number. If it's 5 and above, then then you would round this up, right? If it's below 5, you leave this number the same. All right. And that is your answer. That is the sum of the finite series of the first 8 terms. Okay? And that is finding finite series. Okay? And that's as bad as it gets. Would be a problem like example C. It would be one of the harder ones, because especially on this problem, it will totally throw you off if you do not have parentheses, so make sure you do keep an eye on that one. Alright? But if you do have any questions, please let me know. I'm happy to go over anything with you guys. So, thank you guys so much for watching. Check out the next video to find the sum of a infinite geometric series. Thanks for watching!